Let's quickly review how we build and use classification models. So when we are using supervised learning for classification, of course, we always start with historical data of some kind. Here, I'm not showing all the data. There are several predictor columns that I've just got dots. I'm not showing the data. Here is our target attribute of status, the usual buyer, non-buyer scenario. And what we are trying to do, of course, is to look at the historical data and arrive at a model by which we can say, uh, whether something is a buyer or non-buyer, as a particular case is a buyer or non-buyer, based on the values of the other attributes. So what we really do is we partition this data into training and test. We build a model using the training data, and then we evaluate the model on the test partition. Again, we've looked at this before. The whole idea is that we want to evaluate the model on unbiased data, that is data that was not used to build the model. So at the end of this whole process comes a model, assuming that the model evaluated to be a good model by whatever criteria we are using. So we've got a model. Now that we have a model, we can start using the model to classify new cases. So for example, here's a person with some attributes like state of NJ, age of 25, income of 45,000, gender, etc., all of that. So we apply the model, and the model is going to tell us whether this person is going to be a buyer or a non-buyer. The model is making that prediction for us. Of course, the model could be correct or wrong, but that's what the model is doing. To make things even more clear, typically we won't be forecasting just for a single case. More often, you've got a whole data set with the predictor attribute values known, but the target attribute values are not known because this is completely new data. So for example, let's say you've got a company who's trying to sell some product. They've got a new data file with a number of prospective buyers who have not bought the product. So we don't know whether they're going to buy or not, but we've got all the predictor information like the state, the age, etc., etc. We've got all of that. So what we might do is to run this entire data set through our model. And of course, the model is then going to make a prediction for each one of them as to whether the model expects them to be buyers or non-buyers. Based on this, we may then take further action. So for example, what a company might do is identify all the people whom the model thinks will be buyers or who the model predicts will be buyers, and then send them some kind of a promotional brochure or whatever action you want to take to nudge them closer to the purchase decision. So really, this is how we typically use these predictive. So it's important to be clear about the various phases that go on in the process of building and using models. So broadly speaking, there are two phases that we can think of. One is model development, the other is model deployment. So model development, of course, is the process where we build the model and evaluate it. So for example, we learn on the training partition. So we've got the data, we've partitioned into training and test. So we build a model using the training partition, which is the process we call as learning. The model is learning, the machine is learning the patterns which exist in the training partition. And of course, that yields us a tentative model. And of course, we cannot just start using the tentative model until we know that the model is a decent model. It meets our criteria for whatever we consider to be a good model. So we evaluate this tentative model on the test partition. Okay, that is, test partition, if you recall, was data that we just kept away. We did not use for model building at all. So that is sort of like unbiased, independent data sitting out there. So we get a tentative model from the training partition, and then we apply this tentative model on the test partition, and that yields us a model. Okay, that is, it doesn't yield a new model. It's got the same model, but let's assume that the evaluation is successful in the sense that the evaluation on the test partition says the model is actually quite decent. Okay, so at this point, what we have is an acceptable model. Okay, so we've built an acceptable model based on our historical data. Now we can start using this model for real purposes. So for example, a company may be using it, for example, to check if credit card transactions are fraudulent or genuine. So they've got credit card transactions happening on the field, and every single transaction runs through this model. And the model is going to say, okay, the transaction according to the model is a genuine transaction or it's a fraudulent transaction. And then the company can take appropriate action. So this is a place where the model has been deployed onto the field. It's being used for day-to-day decision making and for day-to-day operations. At this point, the model is just being developed. It's not being used for day-to-day purposes. So once we have an acceptable model, we may put it into production. Okay, so those are the broad phases that you can think of in model. So development, and within development, there are a couple of steps that we take. And once the model is acceptable, we then deploy it on the field and run new cases through it all the time. So just to be clear about one very important aspect about building models. So we've got several predictor attributes within our training data set, right? Within the historical data that we have, we've got many predictor attributes. Of course, it's not necessary that we use all the attributes that are available. We may choose certain attributes to use and choose to ignore certain attributes. Sometimes we will make this decision consciously. Sometimes the method that we use, the classification or regression method that we use, will automatically find out which are the attributes that are useful, and it will ignore the remaining. We'll come to all of that later. For now, we've got a bunch of predictor attributes, and of course, what we do is run these predictor attributes, values of the predictor attributes, through the deployed model, and the deployed model is going to give us a prediction. Right? So for example, this may be information about a person, and the model may tell us, is this person going to be a buyer or non-buyer? Or you may have the attributes may be attributes of a tax return that was filed, and the model may tell us whether the tax return that was filed was a genuine tax return or a fraudulent tax return. Or alternately, these might be attributes of a student, a prospective student, and the model may tell us whether the student is going to be a good performer or a bad performer. So anything. So whatever it is, it's doing classification. The point is that when we use the deployed model, we are going to use a certain bunch of predictor attributes. So at the time of deployment, obviously, we need to ensure that in our model, whatever we use as predictor attributes in the model should be attributes that will be available at the time you deploy the model. This is very important. We should use an attribute as a predictor only if its value will be available at prediction time. Okay, it's very easy to actually fall afoul of this requirement. So for example, okay, not all attributes in historical data are appropriate. Okay, so for example, let's say you've got a bunch of sales transactions, historical information about sales transactions. It may include who's the customer who made that purchase and many other attributes of the purchase. And of course, the total value of the purchase, maybe which products were purchased, all of that information. And an additional item of information that's also there might be the sales tax on that particular transaction. Okay, now when we try to build a model to predict, let's say, the value of the order, okay, the total monetary value of an individual order, right? Now, obviously, because of the fact that sales tax is most often a fixed percentage of the total bill, right? So obviously, sales tax will be an extremely good predictor of the total order value, right? After all, sales tax would be available in our historical data. So we may do some analysis and find that sales tax is very closely correlated with the total value, as we would expect, because it's usually a fixed percentage of the order value, right? So if the order value is $100 and the sales tax is 7%, the total is going to be 107%, right? So you've got 7%, is the sales tax. So for example, if you know the tax amount, then from that you can deduce the order value. Okay, so obviously the column sales tax is an extremely good predictor of the total value. Now, some people unthinkingly might get tempted to use sales tax as a predictor attribute. Now, that is obviously nonsensical, because for a new case, when you have deployed the model, for a new case, you're not going to know the sales tax, because sales tax is determined based on the total value of the order. Okay, so you then cannot turn back and say, I'm going to use sales tax to predict the value of the order. That would not make any sense, because let's say you've got data about a lot of prospective customers, right? And then you want to find out, let's say, what will be the value of the orders that they're going to place. Now, obviously, we cannot use sales tax, because at that time, sales tax is not going to be available till they actually place an order, right? So this is a very important consideration that whatever columns you use as attributes, predictor attributes, you should use them only if their values will be available at prediction time when the model has been deployed. Okay, so that's a very important consideration that we simply should not forget. Okay, so once again, just like sales tax is an excellent predictor of the order value, the date of loan rescheduling might also be a very good predictor of if a person will default on a loan or if a person will start making late payments. Why? Because why do we reschedule a loan? Because a person has some difficulty making a payment, so they reach out to the company, and the company says, okay, I'll reschedule your loan payments and so on and so on. Okay, so obviously, if there is a column called date of loan rescheduling in our historical data, that would be there only for those people who have difficulty in making payments, right? So we cannot turn back and say, okay, if there is a value in this, then that's an excellent predictor of whether a person is going to default on a loan or whether a person is going to have difficulty making timely payments, right? So because this information of date of loan rescheduling is not going to be available for prospective customers, right? That is, you want to take on somebody as a customer only if your model tells you that these are people who are unlikely to have difficulty with making payments, right? So for those customers, the date of loan rescheduling is not an attribute whose value we will have at the time we are considering them to become customers. So this would not be a good candidate to be used as a predictor attribute.